Hey guys, I'm going to give you a quick example of how to find a general polynomial regression line that is not necessarily quadratic. It could be cubic or quartic as well. Cubic meaning that it is a degree 3, quartic meaning that it is a degree 4. So let's just start with some data and see how we would go through this process. So we're going to start by putting our data into our calculator. So if you're on the home screen, we're just going to go into Stat, Edit, and then for list 1 we're going to use our X values. And then list 2 we're going to use our f of x values or our y values. Now if you look at this data, you should notice that this should be an even function just because for example, when you have an input of -3, you have an output of -55. An input of +3 also has an output of -55. So just something to kind of notice about the function as we go. Okay, so now that I've got these into my list, I'm just going to take a quick look at the scatter plot. So what we're going to do is go to y equal, make sure that our plot is turned on. Then we can click second stat plot just to make sure that we're using list 1 and list 2, so that looks good. And then what I need to do, if I go to my graph, I'm not going to see it, but what I can click is zoom, and then I want to go down to zoom stat number 9. Now this is what I want to use to determine if I'm going to be using a quadratic, a cubic, or a quartic regression line. I have to use kind of some context about the graph. So if you think about what the line graph is going to look like, it's going to kind of come up like this and then turn like this and kind of go back. What you want to focus on is the number of turning points. So this graph is going to have, if I were to go up like this, it's going to have one turning point right here, and then it's going to dip down and come back up, so there's going to be a second turning point right here, and then it's going to come up and have a local maximum right here, so that's a third turning point. That's all we have. We have 1, 2, 3 turning points. So you kind of have to imagine if you took like a pencil and kind of sketched through these points, what would the graph look like? So that's what we call the line sketch of the graph. So since there's 3 turning points, that means that the minimum degree of this graph must be 4, because the minimum degree of a graph is always 1 more than the number of turning points that you have. So therefore, this is not going to be a quadratic, because that would be degree 2. It's not going to be a cubic, because that would be minimum degree 3. This must be at least a quartic. So what I'm going to do is I'll go into Stat and then Calc, and you'll see down here there's a couple of different options for regression lines. We've already done quadratic regression. I said this can't be a cubic function, so because of the number of turning points is too high, so we're going to go with the quartic regression line here. So I'll click Enter, let it think for a second. And this is going to give us my A, B, C, D, and E values, and that goes with A going with the 4th degree, B with the 3rd degree, C with the 2nd degree, etc., etc. So if I were to graph this out, let's do this so we can see it. So if I'm going to sketch this, oops. Well, let's see. If I'm going to sketch this out, my function is going to look something like this. F of x is equal to, the leading coefficient is going to be -1, so that's -1 x to the 4th, so I'll just put -x to the 4th. The b value is 0, so let's see, I'll just go ahead and put this in and then we can simplify it in a second. So 0 goes with the x cubed part. Oops. Sorry. 0 goes with the x cubed part, and then the c value is 3, so that's going to go with the x squared part. D value is 0, so that goes with the x to the 1st power part. And then the e value is -1, so that's my constant term at the end. Now, of course, I don't really need these zeros here, so I can just kind of take these guys out, and I'm going to rewrite my function like this. So f of x is equal to negative x to the fourth plus 3x squared minus 1. So this should be a good estimate for my function. In fact, this isn't the exact function. You can tell because the numbers are so nice, the coefficients are so nice. If it was more of an approximation, then the coefficients would probably be kind of ugly decimals. So let's just kind of check this and see if this actually follows pretty well with my points. So I'm going to put in negative x to the fourth plus 3x squared minus 1, and let's just graph that on top of my points. Yeah, and you see that fits very nicely. It's kind of hard to tell right here, but the curve should be going exactly through these points. So there you go. So that's an example of graphing a quartic. Again, if this had only had 2 turning points, I probably would have used the cubic regression, but here we're kind of just focusing on the number of turning points and then using that to make your best judgment in terms of the polynomial.